We are in geometry. We're on lesson 10-11. We are writing equations of circles. Today's date is the 2nd of, I should put this in the right spot, the 2nd of April, 2025. This is not the 4th of February. All right, remind me, what's the equation of a circle? Look back at your notes if you're confused. The equation of a circle is... Eli, are you looking at your notes? What's the equation of a circle? You got it, Evan? Where's your notes?
X plus h squared plus y plus k squared equals 100.
Yeah, that's the old one that we were using. We also have a newer one where we know that these are opposites. Whenever we have opposites, we can switch these out to a minus sign, and we have a better way of writing that one. Do you remember the way that we updated this? What do we write over here on that second part, Evan?
R squared.
Yeah, r squared, because in order to get to the radius, you have to square root it and get rid of this square. And this means that if I have the opposites of h and k, that the center of the circle is where? What are the x and y coordinates? What comma what? Is it positive h or negative h for the x coordinate? Positive h and also positive k. You do the opposite to get to the center of the circle. And then the radius is just r. In order to get from r squared into r, I can just make a note here. To get from here to here, we have to square root. All right. Another thing that's helpful to remember is how to find the distance of a diagonal today. What is the distance of this line? A little bit more than 3, right? Because 3 would have been right there. This one is tilted a little bit. How do we find it, though? That's more important than what it is. Yeah, exactly. The Pythagorean theorem. So let me go ahead and make that right triangle so we can see what's going on. There's my right triangle. And I can say that this length down here is 3. This length is 2. I can pull that triangle out and redraw it a little bit and say if I have a 2 by 3 and I'm trying to find this length x, I set up Pythagorean theorem. Eli, set that up.
2 squared plus 3 squared.
Good. Evan, solve.
4, 13 equals x squared.
It does equal x squared. And then what do you do both sides to solve for x?
Square root.
And therefore, we say that x is equal to the square root of 13. There's a cool shortcut here in a little bit, and I'll show you that once we get there. All right, so let's try an easy question, then we'll move on to a slightly harder question. Write the equation of a circle with a center of 1, -3, and a radius of 4. I'm going to set up the default. You always do this. You always say it's going to be something squared plus something squared is equal to a number. I know that the x and y has to be in here. You don't have to have the x first. I just typically do. You can have the x move over here and the y move over here if you want. Doesn't really matter. So what goes in here? What do I put in for the x? It's like a 1 or a -3 or something like that, right? Eli, go. Good guess, but not quite. Why is it not 1? I mean, it's the opposite. So it's going to be -1, exactly. So if you have a positive 1, make sure that you switch it to a -1. And just to make sure Evan's paying attention, a positive 3. Good. Ooh, we have a harder question now. What goes here? It has a radius of 4. So do I put a 2 down here? Do I put a 4 down here? Do I put a 16 down here? Do I square it? Square root? How do I find what number goes here? Eli has an answer. I want to give some think time on this one. Melly looks like she wants to answer as well. Melly, go for it.
Just square 4.
Just square 4, so I get 4 squared like that, which can be, we can swap that out for a 16. Why did you do a 16 here?
Because it's equal to the r squared.
Yeah.
Worst radius.
Yeah, you're going off of the equation. The equation over here says do r squared. Well, it told us that r was 4, so do 4 squared, 16. And again, just to make sure that everything works out, in order to go from this number to the radius, we square root that number. So the square root of 16 is 4, which is the radius of 4. So everything there matches up. So far, so good. Easy question. Fist of 5 really quickly. Just make sure I get all 4s and 5s before I move on. I've seen 5, 5, 5, 5. Probably, yeah, it's in my desk. All right, let's try a harder example. So this one, I want like 100% full focus. This one is hard if you don't know what you're doing. After you see it for the first time, I'm thinking that you guys will only think it's like a medium level question. I need the equation of a circle, and I know where the center is, but I don't know the radius. I just know that there's another point on the edge of that circle. So I am going to graph this one for you guys so you can kind of visualize what's going on. I will not be giving you a graph on the actual homework, though, for this type of question. You have to do it without any sort of graph. All right, so center's at -4, +2. -4, +2, there's the center. I'll label that one as the center. And the one of the point on the circle is 1, 4. So 1, 4 up here, that is on the circle. This circle is going to go way off the graph. It's probably going to be like, is that going to turn into a circle? It's going to look something like this, I would guess. And I don't know exactly what's, okay, well, it's going to have to be a little bit smaller than that, isn't it? Can I resize this to be a little bit smaller? Maybe it's going to look like that. Sure. Let's go with that. I think this circle is going to look something like that. And I don't know what this radius is. It's probably a little bit more than 2. I just need to know what it is exactly. So how do we do that? First, we can set up the first part of the equation, right? We know that it's going to be x with a number squared and y with a number squared is equal to some radius. And that's going to be the really tricky part, is this one right over here. Valentina, give me these numbers in here first. Yeah, this changes to a +4 over here and -2. Good, you took the opposite of them. The hard part now is, what is the radius? And again, the radius is this distance between these 2 points, right? Oh, wouldn't it be really helpful to know how to find the distance of a diagonal? Because that would be the radius, right? So we do the same thing that Valentina did over here. You use the Pythagorean theorem. We set this up and we say, okay. And again, you have to do this without a graph. That's the hard part. If you want to make your own graph, feel free to. I'm going to make my graph by making a triangle here. That's a right angle. And I can count the distance. Yeah, go for it. Just leave the cell phone. I'm going to count 1, 2, 3, 4, 5. Label this one as 5. Count 1, 2. That length is 2. And we'll set up a Pythagorean theorem triangle with a 5 and a 2. We'll call this one R, because it is indeed the radius of the circle, right? I'll label this one R as well. All right. Help me set this up. Anyone? Melly, yes, thank you for volunteering.
5 squared plus 2 squared equals R squared.
Good. Valentina's going to solve.
25 plus 4, 29, square root of 29.
And I'm catching up. We're square rooting, and we get R is equal to the square root of 29. So that's what the radius is. So what do I do with this again? I have the radius. What number goes here? Do I just rewrite the square root of 29 in this spot?
Just 29.
Yeah, you're right. Why just 29?
Because the square root cancels out.
Yeah, so can I show that though? This is what Melly did. She said, okay, yes, the square root of 29 goes here, but that number that goes here always has to be the radius squared. So this is the radius, this is it being squared, and this square and this square root cancel each other out. And I'm just going to write the 29. And I want to rewrite that a little bit bigger for the notes. There it is. So the cool thing about this one is, even if you get a number that can be reduced, like this is the square root of 32, and you're like, oh, 4 goes into 32, I can go ahead and reduce the radical. Don't reduce the radical, because you can just get rid of the square root and then you're done. That's the number that comes up here. That's my shortcut to you guys. Cool. All right. That's the lesson for today. Fist of 5 on that second problem. You've seen a 5, a 5, a 5, and a 5. All right. Thanks, guys.